In this video, we're going to talk about ion formation and oxidation numbers. What is an ion? An ion is an atom after losing or gaining electrons. Okay, just keep that in mind. Remember that an atom is made of the protons, which are positively charged, the neutrons that have no charge at all, and then the electrons, which are the particles that are negatively charged. An ion is formed when an atom, which is neutral, loses or gains electrons. An oxidation number is the charge of that atom after losing or gaining electrons. Now, you were learning about periodic trends. So you already know that the tendency of the metal is just to lose electrons due to the low electronegativity and the energy of ionization energy, and the tendency of the non-metals is just to gain electrons because they have a high electronegativity and a high ionization energy, make it more difficult just to remove electrons from the last level of energy. That's why the tendency of the metal is always to lose electrons, and the tendency of the non-metal is always to gain electrons. Since the formation of ions depends only on gaining or losing electrons, I'm going to start the explanation by going over electron configuration. And if you're having problem with the electron configuration, you have to go back to that video just to understand the organization of the electrons in different level of energy and in different orbitals. Okay, so I have a periodic table here in front of me. Why a periodic table? Because you know that in the periodic table you're gonna find, between other information, the atomic number. What is the atomic number, Ms. Ramos? The atomic number is the social security number of an element. You change that number, you change the element. Oh, Ms. Ramos, we're so confused right now because you're talking about electron configuration and the atomic number is the number of protons. How the number of protons, Ms. Ramos, is related to the number of electrons? You already learned in physical science that elements, they are neutral, meaning that they have the same amount of protons and the same amount of electrons. So knowing the amount of protons, can you infer the amount of electrons? The answer is yes. Okay, so the atomic number, even though it's not the number of electrons, is giving you that information too. Okay, so knowing that, I'm going to start with my first example over here. Okay, remember, electron configuration just to explain ion formation. And I'm going to start over here with sodium. The atomic number, if remember that for that you need the periodic table. The atomic number of sodium is 11. What does that mean? That in an atom of sodium, you're going to find 11 protons. If you don't have any information about the mass number, which is another video, you're going to have 11 neutrons. And since you have 11 protons and sodium, the atom of sodium is neutral, you have 11 electrons. Now, all of these electrons are going to be organized in one level of energy. You learn about the quantum theory. Electrons, they are organized in different levels following this rule. 2n, you know that the 2 is multiplying the n to the second power, in which n is the level of energy. From this rule, you were deducting that in the first level of energy, only 2 electrons can be accommodated. On the second level of energy, only a electron, and this is mathematics. Second, see, remember that you're going to put a 2 over here. Second level of energy, 2 to the second power is 4 multiplied by 2a. And in the third level, 3 to the second power is 9 multiplied by 2, 18. On the third power of energy, you can accommodate up to 18 electrons. But in my class, you learn that those electrons that are in different level of energy, they are organized in orbital S, P, D, and F. You learn that. You know how many electrons you can accommodate in each of them. I'm not going over that in this video. So the electron configuration for sodium is the one that you have over here. This number, see, if you add the numbers that you have on top of the orbitals, is the number of electrons. 2 plus 2 is 4 plus 6, 10 plus 1, 11, which is the 11 electrons that you're going to find in the nucleus. And this electron configuration is giving you the position of sodium in the periodic table. Because if you look at the periodic table, sodium is located in group 1, which is that number that you have over there, period 3. Okay? That one that you have here in the last level of energy is called the valence electron. Valence electron, and is the one that sodium is going to lose. Why losing the electron? Because remember that sodium is a metal. What is the tendency of the metal to lose electrons? Why, miramos? Why the tendency is to lose electrons? You learn about the octet rule. In order to be chemically stable, an element needs a electron in the last level of energy. If you look over here, in the third level of energy, how many electrons sodium have? Only one. It's gonna be easy for him to let go 1 or to accept 7. Remember that nature is always using the less amount of energy. So it's gonna be easy for him to let go that one. Okay? Pay attention to this. And that's the tendency. It's gonna let go the one. Right now, see, after letting go this electron in the last level of energy, inside the nucleus you have 11 protons, 11 neutrons that are neutral, and then you have 10 electrons in the electron cloud. Now you don't have sodium anymore because you have one less electron, and this is mathematics. 11 positive plus 10 that are negative because are the electrons, do the math, it's gonna give you positive 1. Now, after losing that electron on the last level of energy, sodium is not an element anymore. Now, sodium is an ion, because now sodium has one less electron. Consequently, it's going to have a positive charge over there, and positive charge ions are called cations. That plus 1 that you see in on top of the sodium symbol is called the oxidation number. Oxidation number. And remember that I was explaining in the introduction that the oxidation number is the charge after losing or gaining electrons. How many electrons were lost in this example? Only 1, so 1 less plus 1. Second example, and you have a strontium there. A strontium has an atomic number equal to 38. And even though the atomic number is the number of protons, you know that from that amount you can infer the amount of electrons, which is the same, 38 electrons. When you write the electron configuration of strontium, it looks like this. See that? Last level of energy. That number on top is the valence electron, and that number, that's the quantum number. The number in front of the orbital is the level of energy. You are gonna ask to yourself, it's gonna be easy for the strontium to gain 6 or just to let go these 2? Which one is gonna require less energy? Letting go 2 or accepting 6? Of course, the letting go to is going to require less energy. That is the tendency. Okay, the tendency of the metals the tendency of the metal is just to lose the electrons. Consequently, this is what's going to happen. After losing those two electrons, a strontium is not an element anymore. A strontium is gonna become an ion, because now a strontium has two less electrons. Since you are getting rid of two negatively charged particles, you're gonna become a positive ion. You remember that the name of a positive ion is cation. Okay, miramos, we were discussing sodium and we were discussing strontium, but what happened with the non-metal? Basically the same. You have an example over here. Chlorine, I don't know how you pronounce that. Atomic number equal to 17. Okay, 17 protons is equivalent to 17 electrons, which are the ones that are going to be involved in the formation of ions. Now I'm going to write my electron configuration. You have this over here. So the second level of energy, they have the A electron, but in the third level of energy, they have 7 electrons. So how many valence electrons? 7. So now you're going to ask yourself, remember that to reach chemical stability, they need 8. So it's going to be easy for them to let go, 7, or to accept 1. Okay? Think about that. Let go 7 or accept 1. Which one is going to require less energy? Of course, that accepting 1. What's going to happen here is that the p orbital is going to be completed. And when chlorine accepts an electron, it's not chlorine anymore. Now it's an ion with an extra electron. If we're going to do the math, okay, 17 protons that are positive, plus now we have one more electron, 18 electrons that are negative. If you know how to work with integers, you know that the answer is -1. If that -1 is the oxidation number, okay? So when you write chlorine with a -1 on top, that means that you have an ion, a -1, and a negative ion is called an anion. Chlorine is not chlorine anymore. Chlorine becomes chloride, because now you have an ion. Okay, by the way, that doesn't happen with the metal. Even though they were losing electrons, the name doesn't change. For the metals, the names doesn't change even though they becomes cations. Now, for the non-metal is different. They are negative ions because they are accepting electrons, and once they becomes negative ion, the name is gonna change. That's how you can differentiate between chlorine and chloride, or chlorine and chloride, between the element and the ion. For the metals, they have to, like I have to let you know, if you have an ion or you have an element. How do you know that when we're talking about metal that you have an ion? When you see that charge on top of the symbol. Okay, and I have the last example, because, okay, this is the reasoning behind oxidation number and ion formation, but then I'm going to show you like a simple way to find the oxidation number. Okay, so nitrogen, the same story. Atomic number is equal to 7. I have 7 electrons, so this is my electron configuration, and as you can see on the last level of energy, the second level of energy, 5 valence electron. It's gonna be easy for a nitrogen to accept 3 or to let go 5. Okay, so okay, it's easy for nitrogen to accept the 3 electrons, okay? Accepting, in our simple math, 7 protons in the nucleus plus, now it has 3 more electrons. So I have 10 electrons, do the math. Oxidation number of nitrogen. Oxidation number, nitrogen, positive 3, oh my goodness, what a mistake, negative 3. Remember that nitrogen is a metal. The tendency is just to gain electrons, and this is simple. Metal, positive ion, no metal, negative ions, and it's not nitrogen anymore, it's nitri, okay? And that number over here is the oxidation number. So in the slide before, or in the previous explanation, you were learning about all the reasoning behind ion formation and oxidation numbers. Okay, Ms. Ramos, there's a way for us to find the oxidation number like quick. If we don't have to like write the electron configuration and analyze that. Of course, there's another way of finding the oxidation number. You always need the periodic table. When you're looking for the oxidation number, you always need the periodic table. Now remember that this technique is gonna apply only for representative metals, because representative metals are the one that has one oxidation number. Okay, for transition metals, I'm gonna give you a table with the possible oxidation number that they can show. And for the non-metals. Okay, so let's say, for example, that you want to find potassium oxidation number. So when you want to find potassium oxidation number, you're gonna look for potassium in the periodic table. Potassium is in group 1, meaning that potassium is gonna have 1 electron on the last level of energy. Potassium is a metal, it's gonna lose 1 electron. So potassium oxidation number plus 1. If for your information, okay. All the elements with the section, I'm talking about group 1, all the elements that are in group 1 with the section of hydrogen, which is a special case. Sometimes it's going to accept 1 and sometimes it's going to let go the 1. Okay, with the section of hydrogen, all the metals that are in group 1, oxidation number plus 1, which makes sense. See, group 1, they are metal, they are positive because they form cations, positive 1. All the metals that are in group 2, they have 2 electrons on the last level of energy. So what is the oxidation number for all the metals that are in group 2 plus 2? Because remember that the tendency of the metal is to let go the electrons. How many are they going to let go if they are in group 2? 2. So all the metals that are in group 2 plus 2. Now we're going to move to the third level of energy. You remember that over here you have the metalloids, and the metalloids sometimes they behave as a non-metal. So I'm talking about all the metals that I have in group 13, or is in other periodic tables you're going to find, see, this nomenclature in there. The group 13 is the group 3A, meaning that over here you A means that you have a representative group. So all the metals that you have in group 13, oxidation number plus 3. Okay, now, okay, esto doesn't count because sometimes they behave in a different way, and you have to be careful with lead because lead has more than one oxidation number. But if you are a metal and you are in group 14, in case that you are asked to do that, if you are in group 14 and you don't have more than 2 oxidation numbers, your oxidation number is going to be equal to plus 4. Now, we have a problem over here that we have carbon. Is carbon a metal? Carbon is a non-metal. What is the tendency of the non-metal? To gain or to lose? It's just to gain, and we're in the middle. Remember, they need 8, okay? If we are in the middle, Ms. what is the oxidation number of carbon? If we are in the middle, he's going to lose, he's going to gain. Remember, he is a non-metal, so he's going to gain How many? 4. So the oxidation number of carbon, -4. For all the non-metals that you have in group 15, get rid of the 1, 5 electrons, the last level of energy. How many more to reach 8? 3 more. So oxidation number, -3. For all the non-metals that you have in group 16, get rid of the 1, 6 electrons on the last level of energy. How many more to reach 8? 2 more. They are non-metal. -2, meaning that selenium. So for an oxygen, it has an oxidation number equal to -2. Okay? And you can continue like that. You can continue like that. All the halogens, they are in group 17. How many electrons on the last level of energy? 7. How many more to reach A? 1. -1 because they are accepting. Now, this beautiful group over here, noble gases, do they need to gain electrons? Do they need to lose electrons? Are they gonna form ions easily? The answer is no. That's why we use helium to inflate balloons, because once that the air or the helium is, the gas inside the balloon is released, the helium is not going to react with anything because it's stable, meaning that has, even though it doesn't have 8, just remember that in the first level of energy, only 2 electrons can be accommodated. So all of these elements over here, they do not form ions.